Hello, and a warm welcome to all software automation engineers out there. Today, I want to talk about IT-like PLC engineering. Let me guide you through a complete IT-like engineering workflow in our new automation engineering solution called SIMATIC AX. With SIMATIC AX, we are combining our know-how in automation with methods and mechanisms from software development to provide you a toolchain that suits your needs. This results in workflows that lean on the DevOps process. What is DevOps, you might ask? Well, DevOps originates in the traditional split between software development and IT operations. Developers wrote code apart from operations colleagues who deployed and supported the code. The term DevOps, a combination of the words development and operations, reflect the process of integrating these disciplines into one continuous process. The process is often symbolized by a lying 8 that is separated into several parts that each reflect one part of the workflow. While the individual steps differ depending on the users, they are generally following a continuous workflow for development and optimization. And a similar shift is happening in the world of industrial automation right now, between the operations and the development of industrial applications. And for that, we adapted the DevOps process. In the following video, we will go through one full cycle of the DevOps process. Normally, this starts with the planning phase, where you can plan your changes and implementations. Followed then, of course, by the development, or the part where you actually write the code, as well as the build, the test, and release process. This results in the deployment of the application and, in the last phase, the operational status, which is then followed up by a continuous monitoring to derive further actions and therefore a new planning phase. In the following example, we will show this cycle alongside an optimization project utilizing SIMATIC AX. For this, we will start at the operating phase. This little animation symbolizes the machine running. As you can see, it waits longer than needed in the bottom position. Let's investigate what causes this long waiting position. We do this through our monitoring and tracing capabilities with the current output to see if there is an optimization potential. For that, we can see a number, and later on we want to increase that number, which means higher efficiency. Let's do some live debugging on the program. Here we can step through our application to identify and resolve issues, errors, or unexpected behaviors within it to ensure it functions as intended. At first, we start the debugging, but do not see any results. For that, we need to set log points. We see it does work, but it does not currently give us any meaningful information. To see them, we therefore need to switch to our tracing extension. Tracing is used to visualize the process data in a graphical environment, which helps us to investigate our application over a period of time. Let's install the job, then start it, and look at the live graph of the output. As we can see, the application starts the filling process on the first rising edge and the emptying process on the second edge. Now to the planning part. How can we optimize this process? Why not by starting the emptying process on the first falling edge already? We can achieve this by a simple change of the trigger in our application. To start the coding, we jump right into our program. But wait, before we do anything, we will open up a new branch, which is basically a copy of our existing project that we then can merge later on with the main branch. We do this to protect our current project and to work on a separate instance. With a setup like this, multiple people can work on the same code base at the same time. After that, we make use of our package management system. It is a collection of software tools that automates the processes of installing, upgrading, configuring, and then removing programs in a consistent manner. With it, we install all needed dependencies, for example, the software development kit, a set of tools to build software for a certain platform, in this case, SIMATIC AX. Now let's change that piece of code. To keep our quality standards and to ensure that our changes work, we employ a method that is called test-driven development. For this, we make use of our unit testing framework. We change our existing tests so they register on the falling edge instead of the rising one. Here I can show you a cool additional feature, which is multi-cursor editing. Simply mark all the parts with Ctrl E and then change all the text to whatever you type in. Pretty cool, right? Now we run the tests. And surprise, they fail. Since we haven't changed the program, this functions as our assurance that everything works. Now we go back to our debugging workflow. We set a breakpoint at the right location, run our debugger, and step through until we find the right part of the application to change it. Here, we change the trigger, of course, to start the emptying process from the rising to the falling edge. We run the tests again, and voila, everything is green and works. However, we are not finished yet. Now we need to build our project and merge it into our main branch. We do this by syncing it up with our existing codebase via Git, a process for version control. For this, we use our Git extension. We type in a commit message and in the end commit and push the changes to our repository. A repository is basically a place to store our code. It could be also directly on your device. In this case, we use our open source GitHub community. Let's move over to GitHub to complete the merge and test it within a CI pipeline. A CI pipeline, or continuous integration pipeline, is basically an environment to automatically run, build, test, and release processes. We start by creating a pull request to get the commit. We then add a description and then merge the code with the project. This starts some pipelines, and within them, individual jobs or tasks that run automatically in the background. For example, it installs SIMATIC AX, it logs into it, it builds the project, it compiles it, and then it finishes. It then runs a test job to run unit tests, and if they are successful, everything turns green, and we are ready for the release. Now we move to the release process. We create a new release by opening a new draft and then create a new version. Mind you, this is a GitHub workflow, but you can also trigger it right out of SIMATIC AX via a third-party extension you can find in the extension marketplace. It again builds the project, packs it, and then publishes the library. Let's come to the last job of our 8 steps within the DevOps process. We need to deploy the solution. We go back into SIMATIC AX. Let's look for the new version. We do this by using an update prompt via our package manager. We run apex update, then apex dl or download. A download to the PLC via a script is started. And within it, the code will be compiled and then loaded to our PLC via our SIMATIC AX loader. Once it is finished, the code is deployed. In the monitoring, we can see the values changed, so we identified that the process is running differently. And if we look at our operating machine, it is running smoothly. To make sure everything works as we expected, we go back to our monitoring phase. If you look at the trace graphs, we can see that the tank is filling on the rising edge and emptying on the falling edge. So we did a great job. Now, if you want to do this project yourself, we provide it on our open source GitHub community. Thank